Japan is a land that moves. To survive here, a house cannot fight the earth. It must dance with it. A masterpiece of resilience and tradition, built to stand for generations to come. It isn't about rigid strength, but harmony within the structure. Wood connecting wood.
The secret begins deep within the ancient, mist-covered forests of Japan.
This is the art of manufacturing survival, the Japanese wooden house.
For 14 centuries, builders here have defied earthquakes and typhoons.
Before machines, masters used simple steel and discipline to shape perfection.
The philosophy is simple. Wood connects wood.
Yes.
No nails required.
After the war, the nation needed homes fast, sparking a timber revolution. Today, ancient wisdom meets cutting-edge digital precision.
It begins with Hinoki cypress, grown specifically for strength and flexibility.
Only the straightest, healthiest trees are chosen for structural beams.
Modern harvesters strip and cut a tree in mere seconds.
These giants descend the mountain, destined for the sawmill.
First, the rough bark is stripped away to reveal the clean timber.
Lasers map every curve, calculating the perfect cut to minimize waste.
Massive saws slice the round log into a square structural beam. Fresh wood is wet. It must be kiln-dried to prevent warping later. Sensors ensure the moisture content drops to a stable 15%. Finally, every beam is stress tested. Only the strong survive. Modern architecture begins not with a saw, but with precise digital blueprints.
Engineers simulate massive earthquakes to ensure the structure can survive nature's fury.
Every traditional joint is calculated mathematically to lock together without nails.
This digital DNA is transmitted directly to the automated pre-cut factory floor.
Robotic arms gently load raw timber onto the processing line. High-speed saws trim the beams to the exact millimeter required. Computer-controlled chisels carve deep mortises where other beams will connect.
Simultaneously, cutters shape the tenon tongue, the male counterpart of the joint.
Complex geometries like the dovetail are carved with surgical precision. High-pressure air reveals a flawless cut, ready for a perfect fit. Each piece is stamped with a unique address code for rapid on-site assembly.
For high-stress areas, builders turn to engineered laminated veneer lumber.
Thin sheets of wood are coated in structural adhesive to increase density.
Hydraulic pressure bonds the layers into a beam stronger than solid wood.
Once cured, these massive engineered beams are cut to support wide open spaces. Modern hybrids use concealed metal connectors to reinforce traditional timber joints. Precision holes are drilled to accept drift pins that lock everything together. Experienced eyes inspect the grain and finish, ensuring no structural defects. Digital calipers verify dimensions within a fraction of a millimeter.
Finally, components are bundled in reverse order of how they will be built.
The numbered kit is carefully loaded, destined for the building site. On site, precision begins before the first beam arrives. Surveyors map the exact footprint.
Excavators carve out the earth, preparing the ground for a seismic-resistant foundation.
Steel reinforcement is laid in a dense grid to strengthen the concrete base.
Liquid concrete fills the trenches, creating a solid slab called the betokiso.
Skilled craftsmen level the surface, ensuring a perfectly flat platform.
After curing, the forms are removed, revealing a unified, rock-hard foundation.
The dodai base sill sits on spacers to prevent moisture absorption from below.
Anchor bolts lock the wooden frame directly to the concrete foundation. Scaffolding rises around the perimeter, creating a safe workspace for the assembly team.
Carpenters slot the first vertical pillars into the base, following the numbered blueprint.
Bring it down slowly. Watch the left side. Easy now, easy. Guide it in. Precision pre-cutting ensures the beam's tenon aligns perfectly with the pillar's mortise.
A traditional kakea mallet drives the joint home for a tight, friction fit.
Wooden dowels are hammered in, locking the complex joinery permanently in place.
The structure rises quickly as the grid for the second-story floor is assembled.
Thick plywood sheets are nailed down, creating a rigid diaphragm for earthquake resistance.
With the floor secure, the process repeats, extending the skeleton toward the roof.
Roof beams, called moya, are slotted in to support the upcoming rafters.
A brief ceremony purifies the home, wishing safety for the structure and family.
Diagonal braces, called sujikai, are installed to resist lateral forces like wind.
Modern evolution adds hydraulic dampers to absorb shock during earthquakes. Metal hardware reinforces traditional joinery, ensuring joints never pull apart.
Rafters are spaced evenly, creating the skeleton for the roof's slope.
Structural plywood sheathing ties the roof together into a single rigid diaphragm.
Waterproofing felt is rolled out immediately to protect the wood from rain.
Heavy ceramic tiles are lifted mechanically to the rooftop staging area.
Each tile is hooked onto battens and nailed to withstand typhoon winds.
The ridge is sealed with mortar and capped with decorative tiles. The house is wrapped in a breathable membrane to block water but let moisture escape.
Vertical battens create an essential air gap, preventing mold behind the siding.
Ceramic fiber cement panels are cut to precise lengths for the facade. Hidden metal clips hold the heavy panels, keeping the surface unblemished. Flexible sealant fills the joints, allowing the house to move without cracking.
Gutters are snapped into place to channel heavy Japanese rainfall away.
High-performance window frames are inserted and leveled in the rough openings.
Double-pane insulated glass completes the thermal envelope of the home.
Expanding foam insulation is sprayed directly into wall cavities for thermal efficiency. The foam swells instantly, creating an airtight seal against the humid Japanese climate. Once cured, excess material is trimmed flush, preparing the surface for wall panels. Flexible piping is routed beneath the floor, designed to withstand minor seismic shifts. Wiring is threaded through the timber frame before the walls are permanently closed.
Fire-resistant gypsum boards are secured to the ceiling, adding mass and safety.
Walls are boarded up, transforming the open timber frame into defined living spaces. Seams are taped and mudded to create a seamless, smooth surface for finishing. Durable flooring is laid over the subfloor, often featuring scratch-resistant coatings. Precision carpentry ensures door frames and window casings fit perfectly square. The staircase is assembled from pre-cut components, connecting the floors efficiently. Modular kitchen units are installed, combining modern convenience with compact Japanese design.
Wallpaper is the standard finish in Japanese homes, applied with meticulous care. For the traditional room, measurements must be exact to accommodate standard tatami mats.
Tatami mats are crafted by stitching woven rush grass over a firm core.
The mats are laid in a specific pattern, instantly bringing the scent of nature indoors.
Translucent washi paper is pasted onto shoji screens to diffuse natural light softly. Sliding doors save space and allow the room's layout to change fluidly. As construction ends, protective layers are peeled away to reveal the pristine interior.
With final inspections complete, the protective shell is removed, revealing the finished structure. The manufacturing journey ends here, as the keys are passed to the new owners.
A masterpiece of resilience and tradition, built to stand for generations to come.